We know him as the father of relativity, the wild-haired genius whose equations unlocked the power of the atom. Albert Einstein gave us a new vision of the universe, but his greatest, most elusive dream was a single, elegant equation that could explain everything in existence, a theory of everything. In our world, he died trying to find it. But in this timeline, he succeeded. And in doing so, he didn't just explain the future. He delivered it to us a century ahead of schedule. In the early 20th century, physics was split in two. There was Einstein's general relativity, a beautiful, clockwork theory that governed the grand dance of stars and galaxies. And there was the new bizarre theory of quantum mechanics, a world of probabilities and uncertainties that governed the chaotic realm of subatomic particles. Relativity was predictable. Quantum was strange. The two theories were fundamentally incompatible. Einstein, a man who believed in order, could not accept the randomness at the heart of quantum theory. He famously declared, "God does not play dice with the universe." For the last 30 years of his life, he fought against it, trying to find a deeper, unified theory that would restore order. He failed. The two pillars of physics remain separate to this day. But let's rewind to the Solvay Conference of 1927. The greatest minds in physics are gathered, and Einstein is locked in a fierce debate with the Danish physicist Niels Bohr, the father of quantum theory. In our world, this debate solidified their opposition. But in this timeline, in the middle of his argument, Einstein has a stunning epiphany. He suddenly sees the quantum strangeness he so despised not as a flaw, but as the missing crucial link to his own work. He doesn't fight Bohr. He joins him. The two greatest minds of the century stop being rivals and become collaborators. Their singular goal: to write the equation that explains all of reality. By the late 1940s, they published their unified field theory. It's the instruction manual for the universe. The impact on humanity is not gradual. It is explosive. The first breakthrough is energy. The theory provides a clear and direct path to achieving stable, controlled nuclear fusion. By the 1970s, the oil crisis never happens. The world transitions to clean, compact fusion reactors the size of a car, capable of powering entire cities. Pollution from fossil fuels becomes a relic of a primitive past. The geopolitical map is redrawn overnight, as energy becomes nearly free and accessible to all. The second revolution is even more profound: gravity. The theory reveals gravity as a quantum force that can be shielded, focused, and controlled. By the 1990s, gravitics technology is a reality. Heavy construction is done by silent, floating gravlifts. Transport in cities shifts from wheeled vehicles to personal pods that float silently on gravitational cushions. This technology makes leaving Earth's atmosphere trivial and cheap. The final frontier of the theory is space-time itself. By the early 21st century, the principles for faster-than-light travel are not just theory, but an engineering challenge. The Alcubierre drive, which warps space-time around a vessel, becomes a reality. Humanity is no longer a species confined to one planet, or even one solar system. The age of interstellar exploration begins. So, what does our world look like on June 18, 2025? It is a world without pollution, without energy crises, and without borders in the sky. Geopolitical conflicts are muted, as resource scarcity is a concept from the history books. The great nations are not rivals, but partners in the greatest exploration in human history: the colonization of the stars. Here in Vilnius, the historic Old Town is a cherished global heritage site, preserved under a transparent, climate-controlled dome, while the new city around it is a testament to gravity-defying architecture. The dreams of science fiction have become our everyday reality, all built upon a foundation laid by one man who chose to collaborate rather than confront. We look up at the night sky and see not just stars, but destinations. Einstein's choice to embrace a theory he once hated didn't just change physics. It unlocked human potential and accelerated our destiny by 1,000 years. It begs the question, what other incredible futures are locked away right now? Just waiting for one mind to find the right key. Which of these technologies, limitless energy, control over gravity, or faster-than-light travel, do you think would change humanity the most? Let us know your thoughts in the comments below. And for more journeys into the timelines that could have been, subscribe to Alternate History Explained.